Greetings guys. So we'll be discussing the computational thinking week 4 in this class. So let us start the very first topic, concept of nested iteration using birthday paradox, and in a naive approach, but not any simplified, but it is a naive approach. Okay, let's start the topic right now. First of all, what is given here? Concept of nested iteration. Let us leave behind this birthday paradox and everything. The birthday paradox is just an application, but first of all let's get perfect at concept of nested iteration. What does nested iteration mean? Nested iteration, I'll just write down the definition of nested iteration, and later on I'll just tell you the common misconception made by majority of students. Nested iteration refers to the process of using what? Using one or more loops in the sense iterators. One or more loops or iterators inside another. Actually, in the sense of programming or in the use of programming, loops or iterators are used to execute a block of code repeatedly. Please keep this word in mind. Repeatedly. This is what the use of iteration is. Repeatedly in the whenever we come across the word repeatedly in computational thinking, this word called iteration must strike in your mind immediately. Repeatedly means iteration. So loops are used to execute a block of code repeatedly n number of times. N number of times means any number of times. It can be 1, it can be 2, it can be 10 as well. Any number that the user wants or the programmer wants to repeat. User choice, or better I will write that to be user choice. Okay, I hope that all of you are clear so far. N means user choice, and thereafter and when it is nested, iteration and nesting both are different, but when iterations are nested in one inside one another, they allow you or they allow us okay, they allow us to iterate in the sense, iterate means repetition. They allow us to iterate over a set of values. Over a set of values means you need not make your mind complex. Over a set of steps rather. As values are not introduced to us, we can just tell that over a set of steps also. That is also even that is not a problem. Over a set of steps multiple times, that is what n means. Over a set of values multiple number of times, that is what an iterator does. Multiple times within the outer loop. Within the outer loop, simple outer iteration also. Please don't get confused guys. Both loop and iteration are the same. You need not get confused here. Both of these mean the same. Loop and iteration mean the same. And nested iteration can be used in various tasks. Nested iteration can be used in various tasks. Nested iteration can be used in various, or instead of using the word various, I can clearly tell that to be many also. Even many is also proper word when compared to various. In various tasks such as sorting algorithms, we can do sort algorithms, and we can also apply this for matrix multiplication, which will be coming which will be introduced later on, and important to be and many other applications as well. But what we need to do is we must be very alert and we must be careful with the nested iteration, because there are many conditional statements, conditional operators, or also we can tell that to be iterators. The iterators, there are many iterators on if, for, and while. These are what the three are introduced for us, but these three things are very important, and these three are important as well, but they can destroy the entire process also if they are not suitable for the condition which is present inside the parenthesis. Inside the parenthesis we do have the condition, and if we use if instead of using for, if for is the right option or the right iterator, and we use if, it can destroy, or it can bring a wrong result due to the improper selection of iterator. Or if the right answer is while, and if we used if, then also we might get a wrong answer, and we will definitely get a wrong answer. Therefore it is very important to use a proper iterator. However, it's important to be careful. That's what I said you. However, it is really important to be careful when using nested iteration, as it can quickly even there is a possibility of leading the entire iteration to performance issues if not implemented efficiently. Even this is also a big problem that we can face if an improper iterator is chosen. I just said that we need to be careful. Please keep this in mind, guys. It is important to be careful. This is one reason for which we need to be careful. And the second point is that we need to be careful as it can quickly lead to issues in performance in the sense we are not doing some programming or something like that. That's the reason I'm only telling you issues. If this was some programming class, I must have really told this to be performance or programming issues, but even bringing out a wrong answer is also an issue. So therefore it will, and another point is it will quickly lead to issue. So I have to write this once again. It will quickly lead to performance issues. Performance in the sense not this coding and everything. The performance issues in I'll just write that inside parenthesis. If not implemented efficiently. We did implement it, but in a wrong way. But how come I am telling this to be efficient? How is efficient and how is wrong different? How are these two different? Here I have said you to efficiently use the nested iteration, but here also I said you, but it was in a wrong way, like it was something to be like improper selection of iterator, but here but here I am stressing upon efficient usage. How are these two different? Efficient usage means we need to take care of the number of steps also. For example, think that inside the but here I'll just give you what an efficient and what are different, what and also difference between efficient and this improper selection. Efficiently means all steps must be related. Related means here also it will be related, but I'm just telling you, I'll just give you an example. Consider two algorithms or two pseudocodes where efficiently means there will be all the lines will be interrelated. All the lines will be closely or they'll be closely related, or in another way we can tell that to be they are interrelated. This is what efficiently means. And I'll also tell you the same for this statement. This is statement number 1 and this is some statement number 2. We don't have statement number 2, but I'm just telling you. And how can this be inefficient? I can tell this to be inefficient because here we have, let us consider the right operator. Let us think if is the right operator and this is the statement. If and directly we have a print statement. Only one line just below the conditional statement with the right operator. How can this be inefficient? Means sometimes we can get this to be inefficient because this will be only one line after the first operator, but even this is also a nested iterator. That means just above this if operator we might have some for. Just below if, let us think that there is some for I in range n. Let us think this is the line which is above if operator. So I can tell this to be inefficient because these are 3 in total and this might go out of range. Out of range means for I in range 5, let us think 5. Then we may get 6, but where is the range for I? So this is how I am telling you all that this is inefficient. In this way I can definitely tell you what an inefficient and what an efficient means. So we are done with the concept of nested iteration, and now till so far all these 13.5 minutes I have been only telling you the concept of nested iteration, but not birthday paradox. I'll just explain you the birthday paradox as easy as possible, and you all will understand with great understanding also. Birthday paradox, I'll change the ink as well. Birthday is something which all of us really celebrate, so I'm using gold here. Birthday means the date of birth of a candidate. What do we do while selecting birthday paradox? Birthday paradox means finding means considering a birthday and finding the person having same birthday. And there are two approaches for this: naive approach and a simplified approach. These are the two approaches that we have, and we will be discussing the naive approach here. Naive approach. What is naive approach? The first step that we do is we do select. I'll explain you with the help of an example here. Step number 1 is think that there are 10 students, and also let us think the first student has his birthday on December 2nd. So we wanted to check if rest of the 9 members are having, if any of the other 9 members are going to have the birthday on December 2nd. So immediately what do we do? For in the naive approach, what we do is, as there are 9 cards remaining, 9 cards are remaining, right? So what are we gonna do here? We'll place all the 9 cards like this, one beside other, or all in a single pile called pile 2. These are 4, these are 3, 7, 8 and 9, right? So we are gonna go through each and every card, first 4, second 4 and 9. We'll manually check this December 2nd card with one card after another. So let us think this is December 3rd, hence this is December 2nd and this December 3rd, therefore did not match. We'll move this into pile number 3. And let us think this is January 2nd. This also did not match. We'll move this into pile number 3. March 1st, no, it did not match, pile 3. April 1st, no matching, pile 3. January 1st, did not match, pile 3. But see, here it is January 2nd and January 1st, these are closely related but are not the same. And July 1st did not match, pile number 3, move into pile number 3. November 2nd, no matching, pile number 3. December 1st, it did not match, pile 3. And December 31st did not match, pile 3. What did we do here? We took the first card into consideration. We opted for the first card and kept it aside. From the pile 1, we took the first card which has December 2nd as the birthday, and when pile number 2 has, and we kept all the remaining 9 cards into pile number 2. And now we are going to compare pile 1 card with pile 2 cards. Pile 2 has 9 cards, right? 9 and 1. It is gonna be something 1 versus 9. So we had to manually go through each and every card, and we wanted to check out if anyone has the same birthday as the first card. And if you did observe, this is a time consuming process. Selecting second card, checking it manually with the first card. If it matched, we'll just bring it out and place it in pile number 2, something like that. But here what happened, after the second card is read, again we are placing it pile 3, and again we move into pile 2, and again we manually check with card number 3, manually checking with card number 4, and so on up to manually checking with card number 10. This is what a naive approach is. In general, naive approach is difficult in the sense it might lead to errors also. It might lead the user to make some problematic it might lead the user to bring up some problematic result as well. So this is what a naive approach is, and this is what we do birthday paradox using naive approach. We take one card and we compare that one card with rest of the cards of dataset provided to us, and it is a time consuming process. So guys, let us move into the second topic, birthday paradox using binning. As I said you well before, birthday paradox is a well-known problem in the real world as well, and also in probability theory of statistics, and also in the decision making in computational thinking. What this birthday paradox shows is, this birthday paradox tells us how the probability or how the decision making is done on a shared birthday in a group of people, right? I think all of you have understood. I said you that birthday paradox is a theory that shows us how the probability of sharing a birthday, how the probability of a shared birthday and how the probability of making a result in terms of birthday in computational thinking is done in a group of people, which is the data set that we are talking about, is higher than one would think. Then how can we solve this birthday paradox? This birthday paradox can be solved using concept of nested iteration, which we are discussing here. Concept of nested iteration, this is what we are discussing about. And also we can solve the same using binning as well. So therefore, in the birthday paradox problem, we want to find how many people or how many students have the same birthday or share the same birthday as well. To solve this, we can use nested iteration along with binning once again. First we consider the data set, right? First we consider which data set should we consider here? I think it is the scores data set. We should consider the scores data set because the scores data set have the birthday of each and every student. Scores data set has name, city, what else does this have? Name, city, gender, and mathematics marks. Not gender, just after gender we have the DOB, which is date of birth, and this is what we want here. And after that we have math mark, and after that we have physics mark, and after that we have chemistry, and after that we have total. And above all we have card ID, which is 0, which is 1, which is 2, something like that, up to number 30. So the only data set that has the date of birth is course data. So we need to think about this course data. This course data set has date of birth. So let us take course data set with all the other fields being neglected. Name, city, gender, MPC, total. We do not want all of these, but we might need the name here because we need to note down the name of the students who share the common date of birth. So here we need only DOB is the primary condition and name is the secondary thing that we want here. But how can we solve it using binning? First we consider the data set which is scores, and then we iterate through each and every person or every student in the group, and then we increment that particular birthday if found a repetition. When can we find a repetition? When they only share the same date of birth. So guys, binning, I think this is somewhat new to you. It's not only new to all, but it is not only new to you all, but it is also new for everyone who is preparing towards qualifier. Binning will be introduced only in this week number 4, but not in any other weeks like week 3, week 2, week 1. And binning is such an easy topic to understand or to clearly understand, because in binning we only do create bins. We only do create bins accordingly to the data set provided. As date of birth has 12 months, we create bins with all the 12 months separately. So January is one bin, February is the second bin, March is the third bin, April is the fourth bin, April, May, I'll just write down June, June, July, August, September. These are the bins that we are creating one after other. September, October, October, November and December. These are the bins that we have created, all the 12 bins. So what do we do here? We just divide the students data from the course data set, I mean the date of birth data from the course data set into their corresponding bins based on the DOB. If a student was born in January, we bring his data, or we just insert his card into January. If we find a student having his or her date of birth in April, we just put his card or her card into the April bin. If we find a student having his or her his or her date of birth in June, then we place his or her card in June. So as a summary, what I want to tell is the date of birth of a particular student will be read initially, and thereafter, depending on his or her month of birth, the card will be put into the respective bin. It can be from January to December, both inclusive. Will be put, his or her card will be put in relevant bin. So this is what binning is. So how can we solve birthday paradox using bins? Binning is done, and now bins. If we have considered that I personally have 5 students, not 5, it will be so small. I personally have 10 students. Let's consider that I am giving some home tuition and I have 10 students attending to it daily. And now let us say that the first student number 1, he has his birthday in January. Second student has his birthday in February. Third student in March. Fourth student in July. Fifth student in November. Sixth student in what can I tell you, in October. Seventh student in December. Eighth student in January again. Ninth student in September. And 10th student in, what can I tell you, in Jan again. So we have the raw data I have the raw data with me. I wanted to find out the students having same birthday. Let us say these are the months, and now I'll give some numbers as well. The first student has his birthday on January 11, February 14, March 1st, July 5th, November 20, October 4th, December 2nd, January 11th again, and September 5th, which is Teachers' Day, and again January 1st. Now we'll put the students into their corresponding bins. January 11 will be kept in January. February 14 will go into February bin. March, instead of drawing like this or making it further complex, I'll just put the card number into the bin. 2, 3, 4, November is 5, October is 6, and December is 7. January has 8 as well. Okay, and now September 5th goes into September, and now coming to 10th, which is January 1, which is the 10th card. And now here we have the raw data being put into their bins, and now we'll do checkout. Except the January bin, all the other values or all the remaining 11 have only one value, so we can neglect them. Here in the first bin, which is January, we have three values: card number 1, card number 8 and card number 10. So what can I do here? Here we have most of the values lying in the January bin, so there is a high probability of students having same birthday among these three cards. So we'll just verify if anyone has. So the first card has his birthday on January 11, and the 8th card has her birthday on January 11. So card number 1 and 8 are having same birthday, and card number 10 has his birthday on January 1st. So it is not matching, and card number 1 and card number 8 are matching with same birthdays, which is January 11. If you observe here, the process has been made into here. The process was simpler when comparing to naive process, right? We need to bring up one card, and that one card will be manually checked against all the remaining cards. This makes a big process and time taking process. But here, if when used bins, it made the process shorter and faster also. Therefore, this is what binning is. This is how we solve birthday paradox with the binning. So now we come to the next topic: importance of binning to reduce number of comparisons. That's what I have explained you just now, but again it is necessity, or it is required to explain you all why it is as it is a topic, I need to explain importance of binning once again. Okay guys, I'll just explain you why it is important to reduce number of comparisons. Okay, I hope all of you are clear with all of you think why it is important from the previous explanation, which is this binning, birthday paradox binning. And now I'll make it clear once again. Please wait a second guys, I'm drinking water. Fine guys, I'll start my explanation right now. So binning is a technique used in computational thinking. As far as the syllabus is concerned, I think I need not write this, time can be saved. Binning is a technique used in computational thinking to reduce the number of comparisons required in nested iteration. This is what all of us know so far. It involves dividing the data, or it involves separating the data into smaller groups. This is the main point to be noted. Separation of data elements is done. Please note this down guys. Separation of data elements is done to reduce the number of comparisons. It is based, and this should be based on some criteria. Based on some criteria only, we need to separate the data elements. Criteria means, in the previous lecture, in the previous explanation, I had the criteria to be months in an year. I'm just talking about this January, February, March, April. These are the criteria on which I separated the data elements into bins, such as and the criteria can also be value of a variable or the geographical location, something like that, or the starting number of or the starting digit of a contact number. And by reducing the number of data points that need to be compared, binning can greatly improve the efficiency of algorithms, pseudocode, procedure, whatever in computational thinking. Binning can, but in summary, I can tell that binning can improve the efficiency, and also it can also lead to correct and accurate result. I think I am clear here. Binning can greatly improve the efficiency, accuracy, and it can bring out the right result required by the user. And binning can also greatly improve the efficiency of algorithms that rely on nested iterations to be specific, that rely on nested iterations such as classification, algorithms, clustering. It is not introduced to you. This is especially true for large data set. Large data set means we have shopping bills as our large data set. Binning can greatly improve the efficiency in bringing the right result. Okay, I think I need to be clear. Efficiency in bringing right result. Why am I stressing on the word right here? If binning is not followed, we follow the naive approach in which there is a high probability of getting a wrong answer also. So efficiency in bringing right result can be achieved by using binning, and binning can also improve the efficiency of algorithms. Efficiency of algorithms that completely rely on nested iteration. One second. Yes, completely rely on nested iteration. I said you completely rely on nested iteration, as it is somewhat yes, completely rely on nested iteration, that efficiency of algorithms can be made simpler. This is especially true for large data set. Once again, this is true for large data set. Why is the efficiency needed in the case of large data set? That is because there is a big difference in bringing out a right result between a data set having 5 cards and between a data set having 500 cards, right? So efficiency is very much needed for large data sets. This is the reason why we use binning for large data set to get an appropriate result also. So, and now comes the next point. For example, what can I say with large data set means, as far as our computational thinking is concerned, the largest data set so far that we are introduced to is shopping bills, right? Each and every one of the students studying in the qualifier process knows this, but I need to give a generic example also. For example, imagine that you are working with a data set that not you but exactly a student who is only reading, whose subject is only computational thinking alone. For example, think that the student is working with a data set that contains age, income. Let us say he is working with a company data set, age, income and location. Location means the place where he resides, home. And co-employees of his team. Co-employees of his team and also his team leader. And what else can be used in employee data set? Team leader and age, income has been used here. Co-employees of team leader and number of projects done. I think I am clear with the dataset elements. These are the fields which are present in the dataset. Okay. So now if we wanted to group these people or group these employees based on their income, this is what most of the companies do. They separate their employees on basis of their income and on basis of their age and on basis of their projects done, because marks show only your concept, but they do not test your practical knowledge. This is where most of the companies fall into trap. But what's good is that we need to have practical knowledge of the concept that a student has. But exams only show the concept but not practical knowledge. Now let us think that actually we want to sort the employees, or we want to filter out the employees having an appropriate age and income to be high and projects done. Why are we choosing these three fields is that the co-employees of a team are well known to the team leader, and the team leader has some 50 members as his team. So all the remaining 49 would also fall under this filter. So team leader is not chosen, and all these 49 means definitely this 49 will be in this co-employees list. So this is also not took. And what is the location? There might be some n number of employees in his location, so this is also not chosen. The only fields that are chosen is age, income and projects, AIP. So we are grouping these employees into age, income and projects. We should definitely use binning here, because we are dealing with a data set which has 5000 entries. Say for example, this data set has 5000 employees. As this number is very high, we need to separate them using binning. Based on these three variables, we are doing binning here. This would make the process much easier to compare, to analyze, to make some quick understandings and everything, since we only need to compare people based on these three variables. Based on these three: age, income and projects done by him or her. See here also, this would make it much easier also, because I said we want to compare and analyze the data, and since we only need to compare people within each bin or within the bins that we declare. Here the bins are age, income and project. These are the three bins, and we sort we sort the employees based on these three bins within each bin, rather than comparing everyone in the data set. As I said naive approach won't work out here. Just now I said that we rather than comparing everyone in the entire data set, what my statement means here, the first employee will be compared against all the 4999 employees by manual checking, which takes a lot of time. Therefore, binning is now you will understand what importance binning has. The importance binning has will be shown you right now. This 1 versus 499 is not done when binning is not followed. I mean, when binning is not followed, then we only have this option of 1 versus 499, and when binning is followed, we are based on these three things. Even here based on these three fields, but it is 4999 versus 1. So overall, I can say that binning can be a powerful technique for reducing the computational complexity. What does this computational complexity means? Computational complexity. This will lead to computational complexity, and it can be reduced when nested iteration is when in the case of nested iteration. Then this and in binning can also. And what is the advantage of binning? It can reduce the computational complexity, and also it can improve the efficiency of algorithm. I can tell that to be efficiency of, this is too long, again it's long, efficiency of algorithm based answers. The efficiency of algorithm based answers can be improved, right? This is what the advantage of binning is. I mean, not advantage actually, yeah, the importance of binning is. I hope you are clear so far, guys. And now binning, and the next topic is binning to avoid complexity of nested iteration. Again we need to read the same. Binning to avoid complexity of nested iterations. This is the new topic. Once again, binning is an important technique that can be used to reduce. Actually, I got habituated to read this statement because this statement is what I prepare personally, which is the definition of binning. Actually, binning it is an important technique that can be used to reduce number of comparisons. The number of comparisons can be reduced. The number of comparisons can be reduced in nested iteration. In data analysis and in data cleaning and in bringing out results based on data set, this binning can be used. And the secondary definition of binning is that binning is the process of grouping a data set, or apart from telling that binning is the process of separating and creating bins, which is a regular definition, I can tell you all that binning is some sort of grouping a set. Grouping a set of continuous values. I did not tell you what this continuous values is. Continuous values into smaller number. Into a smaller number of bins or intervals. I request you all not to make your mind complex by reading all of this which is written here. It is definitely and accurately the same like creating bins, but it is somewhat in a new terminology. That's it, nothing more than that. And the third thing is what is binning to avoid complexity of nested iteration. Whenever we are facing or whenever we are having nested iteration, we can reduce the computational time. That is what I said you using naive approach. This is what naive approach is, right? Where is naive approach? Yes, this is the naive approach. I said you in the very first explanation that naive approach takes up more time. That is what that is what is reduced here when using binning. Binning reduces the computational time. To be more specific, I need to explain this part again, but I'll explain in a short time, which is 2 or 3 minutes. Binning can significantly reduce computational time by reducing the comparisons needed. Instead of iterating through each individual, so that means 1 versus 4999, 1 versus 9, something like that. Instead of iterating through every individual versus one individual, we can say that we can simply iterate through the bins. Once a bin is declared for use, we can simply iterate through the bin rather than is 1 versus 9, 1 versus 10, such things. We can simply iterate through the bins and we can perform calculations on the values which are present in every bin. This is how we reduce the computational time. Right. This is how we reduce the complexity, the first reason. And now the second thing is improves data simplicity. I think this is something you have heard just now. Data simplicity. What does this data simplicity means? Data simplicity means, I'll explain that also. Binning can also improve data simplicity by grouping similar values together into bins. What does binning do? The binning only does separation of data into bins. Instead we can write bins. Bins will be created while binning. Binning can also improve data clearance. Not data clearance, actually we can tell that to be I can simply tell that to be data clustering. We create the data into similar clusters by grouping them into similar values together into bins. This can help the user or this can help the candidate doing binning by who is doing the binning to identify patterns, and also the user can identify trends in the data more specifically and more easily, and it helps the user or the one who is doing binning. It will help the user in clearing the data more easily, and also it makes easier for him or her to communicate the accurate result to others. Result is different from accurate result, so we can tell that to be accurate result. We will get the accurate result. And the third thing is it will help the user with data cleaning. What is this data cleaning? As I've said you here, data cleaning means age, income, location, co-employees of team leader, projects. Here how does binning help the user to clear the data cleaning? Here we have taken three bins: age, income and projects done. I have said to you that why don't we take location, co-employees and team leader? Once if we consider team leader, all the remaining members of his team except this one will also fall under the category. Say that we are taking one employee and rest for 49 members of the team will also fall under this filter, right? So it is again so the bin in total contains this 50 members when team leader is taken. So that's the reason we did not choose team leader. If chosen, we'll again have his entire team in the bin of team leader. That means we'll again totally get the entire data set of 5000 members. What is new in this? So this is not what we want. We only want this one member of his team by neglecting the remaining 49. And for that reason we did not choose team leader. So this is how data cleaning this is how data cleaning is met. So co-employees of his team and team leader bring up the same result. Co-employees means 1 plus 49. It is again 50. And team leader is 1. He is one candidate. But all his employees we are 49 in total. Therefore 1 plus 49 is 50. So this is how data cleaning helped us in the second part. And what is the third thing? Location. Think that the office is in Bangalore. Not Bangalore, let us say in Chennai. Because IIT is in Chennai, let us consider his or her office to be in Chennai. To be specific, there would be n number of employees who reside beside his house, something like that, or in his colony. Think that he lives in a gated community, so there is a high probability of other employees living in the same gated community. In that way we might not get 5000, but we might get some 3500, which is again a large data set. So this is how location is not taken. So this is how we are being helped with data cleaning by using binning. I hope you all are clear, guys. So by grouping or by binning similar values together, we can streamline the analysis process to take some decision. And also binning can improve the accuracy and efficiency of our result. Accuracy and efficiency, right, guys? I don't understand why I am getting this C and Y together all the time. Accuracy and efficiency is perfect when binning is used in the case of nested iteration. So this is how binning helps us in the case of nested iterations. And now procedure to find out the same DOB for different students. Different in the sense for in a class or in a university. That is how different student means. So what do we do in this case? I'll just tell you the procedure for this. We'll just collect the date of birth. This is what the procedure that we are following in this course dataset. What do? We collect the DOB. We collect the DOB of all students. From a data set, and we use nested iterations. We use nested iterations to compare students' DOB with all the other students' DOB. Use nested iterations to compare each and every student's date of birth with all the other date of birth by following or by using nested loops, or by using the naive process, which takes time actually, or by creating bins. This is what the second step is. And the third step is, if you are using nested loops, then within the inner loop, compare the date of birth of the current student, or I mean the student who is outside. Outside means whose card is picked up. Consider that the card number X is picked, and it will be in the outer loop, right? What I'm telling is that within the inner loop, compare the date of birth of current student and with the date of the student who is currently picked up. This X is picked up and kept into loop number 2, I mean table number 2, and the current student is Y, and their date of birth are being compared, right? So if they have the same date of birth, count it as a match and increase count. Count is equal to count plus 1. Please do this if it is found to be a match, right? This is what a nested loop does. And why do we follow nested loops? The nested loops are to be followed because one, to iterate through each student in the data set, and the other, I mean the inner, this is the outer loop which does iterating through each and every student, and the inner loop does iterate through all the remaining students. Inner loop is used for iterating through all the remaining students, and the outer loop is done to iterate through a student, I mean through students slowly, by keeping some I as a variable for I in range or something like that. Okay, I hope you understood what an outer and inner loop does. And I also said you what inner loop does. Within the inner loop, we compare the date of birth of current student with the date of birth of student in the outer loop. In the outer loop there is X. No, in the inner loop we have X, and in the outer loop we have Y. We compare with Y. First the card is met. First the card is read, which is X, and it is put into table number 2. And then we picked up card Y, and we are comparing card Y with card X date of birth. And if it is matching, then we increment count by 1. And also after that we need to increase I is equal to I plus 1 for the outer loop, for I in range 30, if it is 30 students, right? So if I is not increased by 1, I will always be 1. So the card number 1 will be infinite times read. So that's the reason we need to increase I value as well. Overall, as a summary, I can tell you that overall finding 2 or more students sharing the same date of birth involves using nested iteration. Nested iteration means completely and differently you must use two iterations, which is outer and inner, and I have also told you what the outer iteration and what the inner iterations do. And using these nested iterations is done to compare the date of birth of each students with we can tell all the other students in the data set. This is what procedure to find same date of birth for different students is. And concept of fair teams. What is a fair team actually? Fair team, consider that we have 5 students with us. I'll just explain you everything with example. The best thing I can do is I'll try giving you practical knowledge, but along with theoretical knowledge also. This is how a student becomes perfect in aspect of learning something which is new. So let me consider that I have 5 students and I have the scores also. Student number 1 has, I will just write MPC. Student number 1 has 90 in math, 80 in physics, and 16 chemistry due to organic chemistry, which I find it has a headache as well. Personally, I feel that to be a big headache, organic chemistry. Let us keep that aside. And the second student has 95 in math and 81 in physics, and chemistry as 80. And third student has 80, 80, 80. All 80s in all the threes. I mean in all the three subjects. 75, 70 and 76. And the fifth student has 77, 77, 75 and 50. So what is concept of fair teams? Fair team is developed when a student having higher marks helps the student having less marks than that student. For example, I can tell student number 1 can help has 90 marks in mathematics, and he can help any student who has less than 90. I can tell that the first student can help students 3, 4 and 5. He can help students 3, 4 and 5 only in mathematics. And student number 2 can help 1, 3, 4, 5 because all of them have less marks in mathematics when compared to his marks. This is what a fair team means. Any student who has a good score than the other student, he is suitable to help that student. This is what a fair team is. So in physics also the similar pattern is followed. Student number 2 can help student 1, 3, 4, 5. And in chemistry the students 2, 3 can help the students 1, 4 and 5 as they are having similar marks. 2 and 3 are having same score in chemistry. So they can be together and they can help student number 1, 4 and 5. Right? So this is what concept of fair teams is. And guys, this is the end of week 4 class. I hope you all understood week 4 easily. That's why we had to keep learn with ease. Learn with ease. Okay guys, this is the instructor of CET of IITM student community. Thank you for watching this lecture. Please stay subscribed as well. Thank you guys.